So hi everybody, this question was asked to do, which was number 3 from IS1a. It's instructional segment 1a. So basically it says light travels at a speed of 3 meters per second, so that's going to be useful in a vacuum. The approximate distance between the Earth and the Sun is 150 times 10 to the 6 kilometers. Yikes. If the sun suddenly vanished for whatever reason, how long would it take for the people of Earth to notice? And then they give me this conversion factor, which I'm going to use later on. So what I did is I drew a diagram. So I got the sun on the left, the Earth on the right, and then I also wrote down the distance between them. So I'm going to say, let's say that there's like a ball, a photon, right? Or just a chunk of light. So I got a chunk of light, and what they're saying is how fast that chunk of light moves through space is 3 times 10 to the 8 meters per second. So it takes time for, and I'll draw, so let's say like this is the velocity. That's how fast the chunk moves, and it moves at 3 times 10 to the 8 meters per second. So it's going to take some time for it to reach Earth, right? So you can probably imagine, right, there's a bunch of little chunks of light. All of them are approaching Earth, but all of a sudden, like, if the sun suddenly vanishes, then I no longer have light going. So there's going to be, blank happening, but it's going to take the last photon that hits, or the last chunk of light that hits. It's going to take however long that it would take for a light traveling at this speed to go this distance. It would take that duration of time before the Earth doesn't detect the sun anymore. So let's go ahead and bring the sun back. Hopefully, I didn't screw up too much. There we go. So that's kind of what's going to happen. So I basically need to figure out how much time it takes to go this far. And so what I'm going to use is the fact that the distance is equal to the speed divided by, or times the time, or this really comes from the speed is equal to the distance divided by the time, or the displacement, we could say in this case. So I need to isolate time. So I'm going to do that. I'm going to divide both sides here by v. So v cancels out. And I get that the distance divided by the speed, or the velocity, is equal to the time. So the distance is 150 kilometers. So that's going to be, that's going to be my distance. Although, well, I know that the speed is 3 times 10 to the 8 meters per second. That's what this is right here. So I can write that in. So it's going to be 3 times 10 to the 8 meters per second. But then the distance is in kilometers. I need to convert from kilometers to meters. Well, they told me up here that 1 kilometer is 1,000 meters. So I can say, all right, 150 times 10 to the 6 kilometers. And then I do conversion just like I did back in chemistry. So it's going to be 1 kilometer is 1,000 meters. So I put the kilometer on the bottom because I want to cancel it with that kilometer. So I get 150 times 10 to the 6 times 1,000. And if you write that out, let's see, let's just go ahead and throw it into Desmos. So I'll go to Desmos. Plug it in here. And again, what I'm doing is 150 times 10 to the 6. So I'll put that in parentheses. So 150 times 10 to the 6, and I'm multiplying that by 1,000. So the 1 doesn't really do anything, so I get 1.5 times 10 to the 11 meters. And then I can work this out. So 1.5 times 10 to the 11 divided by 3 times 10 to the 8. And by the way, that's meters. So that's going to give me So I'll just use this answer. So that answer divided by 3 times 10 to the 8. All right, and that gives me 500. So 500 seconds, because seconds is my unit. So I got 500 seconds. Seconds my unit because the mass or the meters cancel out, and I get 1 over seconds, but it's in the denominator, so that seconds then gets flipped up into the numerator. So I could say this and I'd be completely fine, but I want to get a better, I don't know exactly what 500 seconds is, so I could convert that to minutes. So because I know that there is 60 seconds in 1 minute, and this will give me, so 500 divided by 60. And I get 8.3, so about 8 minutes, so 8.33 minutes it would take. So yeah, if the sun suddenly vanished for whatever reason, it would take that much amount of time for us to even notice that it happened. Pretty cool. All right, hope that helped. Bye.